Alan Turing was an English mathematician, computer scientist, and wartime codebreaker, considered by most to be the father of modern computing. He studied mathematics at Cambridge University, where his pioneering work in theoretical computer science first led to proof that automatic computation cannot solve all mathematical problems. This concept, known as the Turing machine, is considered the basis for the modern theory of computation. During the Second World War, Turing worked at Bletchley Park, where he played a vital role in deciphering messages encrypted by the German Enigma machine and developed new techniques for decoding messages on an industrial scale. A contribution that many believed helped shorten the war by more than 2 years and save an estimated 14 million lives. After the war, Turing was recruited by the National Physical Laboratory, where he designed the first complete specification for a digital computer. Had it been built, Turing's groundbreaking blueprint would have been vastly superior to any of the earlier computers at that time. In 1948, Turing joined Manchester University, where he directed the computing laboratory and developed a body of work that helped to form the basis for the field of artificial intelligence. Turing was prosecuted in 1952 for homosexual acts and accepted chemical castration treatment. He committed suicide in 1954. In 2009, British Prime Minister Gordon Brown made an official public apology on behalf of the British government for the appalling way he was treated. Queen Elizabeth II granted him a pardon in 2013.
My privilege to welcome you, one and all, to the BCS and IET Turing Talk 2019. That's me just up there. Did you notice the music that was on as you came in? Vangelis's classic soundtrack from Blade Runner set in 2019. I'd like to assure you there are no replicants here tonight, as far as we know. Our insight speaker we're going to start off with is Nadia Abouayoub. Nadia is a strategist improvement lead and specialist in AI in the financial sector. Her theme is this: AI and us, the presence of AI in our day-to-day life. Nadia.
Can you hear me? Is that? Oh, now it sounds better. So first of all, it is a great pleasure for me to be here tonight as the Insight speaker for the IET BCS 2019 Turing Lecture alongside with Dr. Krishna Gummadi. And I wanted to thank you all for taking some of your time tonight and come to exchange some thoughts and ideas related to AI and us. When I focus on AI, there's two aspects that I like to look at. As a professional, I like to see on how AI can be applicable to my industry or to industry in general. And as a human being, I like to see on how AI can be, how we can make AI more understandable actually for the general public, because I do consider that it's very important to have the general public understanding the AI, what's possible to do with artificial intelligence and what cannot be done with artificial intelligence. The reason why is, if you see in the media, there's been quite a lot of discussion about AI, the dangers, and the fear that we can get from artificial intelligence. Related to understanding an AI, I would like to quote Marie Curie. So Marie Curie, who was a Nobel Prize in physics and in chemistry, pioneer scientist in radioactivity, once said, "Nothing in his life is to be feared. It is only to be understood. Now it is time to understand more so that we may fear less." And I would like to echo what she said, because I feel that nowadays it is an important topic to try to understand artificial intelligence for our science. So first of all, why we should look at that, because I do think it's important to look at the democratization of the understanding of AI with the general public. So how I would like to tackle that? The first thing that I would like to do tonight is let's assess our environment. Let's look at our relation with artificial intelligence. Then let's move and look at our concerns, which are valid concerns, and look at AI and the ethics related to artificial intelligence. And then once we look at that, because artificial intelligence has moved for more research field towards mainstream, so let's have a look at AI within industry, which is impacting all of us, either as customers or actually as a workforce. And finally, let's zoom of artificial intelligence. And I would like to conclude this Insight talk with our futures and what's coming up. So let's start first of all, our relationship with artificial intelligence. Sorry, I hope not losing the voice at the beginning of the talk, that won't help. So first of all, let's have a look. What is AI? What is the phenomenon? Is it new? And the reason what I would like to look at its evolution is because it's important to understand where it's coming from in order that we can evolve from there. Artificial intelligence concept, as we can see with Alan Turing and the intelligent machinery, is a concept that's been existing for, our science has been evolving for more than 50 years, starting in 1956 with the fathers of artificial intelligence, such as Marvin Minsky and John McCarthy. John McCarthy himself defined artificial intelligence as being the field of study that gives computers the ability to learn without explicitly programming. I'm moving forward to Archer Samuel, actually, in 1959. So, and then actually the science, artificial intelligence being the science of engineering and making intelligent machine. Then the definition I gave you was actually from Archer Samuel in 1959, which was related to machine learning. So we hear quite a lot of machine learning, which is a concept that has been existing for quite a while. So when we look at AI, we can see that it has been evolving, and that comes to my second point of artificial intelligence in our day-to-day life. It's been in our phone, in the predictive analysis, and obviously our series. So now it has moved on into our day-to-day life. So as an individual, well, our relation is we have to learn. So this building our learning curve related to artificial intelligence itself. One example that I quite like to look at is, for example, cycling. So when you look at bicycles, which were beginning of the 19th century, when we look at them, if we look at the penny farthing bicycles, do you know which one, with the one wheel? Yeah, so the penny farthing, we love mountain biking, so we definitely wouldn't do any mountain biking nowadays with a penny farthing. But actually we could see that the engineering around the bicycles have evolved. So similarly with our science, there are certain concepts, and it will carry on evolve with our needs, with our requirements as well. So let's move on now to ethics. We see quite a lot in the news about concerns, valid concerns, and I would like to focus just on two. The first one I would like to focus on is actually the unbiased. I will not go too much in detail since Dr. Gummadi is going to cover his Turing lecture about this. But I would like to say that, for example, the university, a couple of items that will be quite good for you to take away and to have a look. The University of Bath, I have research directed by Dr. Joanna Bryson, where they're trying to see and how human prejudices could infiltrate into AI systems, and then how that could be actually very dangerous for us. And they focus on what they call standardizing ethical design for artificial intelligence and autonomous systems. So this is one of the concerns, but we are working on that. There's different initiatives going on looking at this aspect. So now let's look at another point, the lack of trust. The lack of trust with artificial intelligence, and then when I'll move on a little bit later, I will give you a couple of examples of initiatives being done on that. But the lack of trust is we would request more transparency. And that takes me to the current debates. So related to the current debates with the transparency, we want to be able to see as well the fairness. And Dr. Gummadi could actually help towards that. The second aspect is the robustness. So for the safety and ensuring that individuals know that algorithms do have sometimes errors, and it is important to be aware of it. And that takes me to the third current debate which is going on is explainability. When you see how you can explain the decision. So regarding the ethics and AI, if I could say there's a couple of points that you can take away and think and read about it. For example, the University of New York, the laboratory of Dr. Kate Crawford, has been working with Microsoft basically to work on fate being fairness and accountability, then transparency and ethics in AI. So they're trying to bring together to have a more responsible AI. The other initiative here that we have is in the UK, the Digital Catapult, which is trying to work towards an ethical framework in order to be able to design responsible AI. So we look about with but we're actually addressing these issues. So now let's move on, because as I explained, AI has moved from research, moved on into more mainstream and by the industries, and actually incorporated within industries. So if we look, in 2016, Carl Schwartz, the founder and the chairman of the World Economic Forum, explained a new concept that our society is going through and called it the fourth industrial revolution. So by that, so let's have a quick look about the other revolutions. So you have the steam and the water, which helped actually mechanize the production. You had electricity, which helped actually mass producing, and finally information technology, which helped automating the production. And he foresaw at the time that he foresaw that actually artificial intelligence will be our fourth industrial revolution. And it is actually impacting our society. So the Gartner survey estimated as of 2018, 21% of the CIOs are already piloting some AI programs within their company. So why am I mentioning industries now? Because as a workforce, as a consumers, we need to know that actually AI is being used as well by the industries. So what I wanted to do when we look at industries is to focus just on a few with the time that I've got. So the first one is healthcare. So how could we use AI within healthcare? So as you might know, there's diagnosis, there's personalized medicine, and as well, we could look at patient monitoring. It estimated by 2021 that what it's called AI healthcare will hit $6.6 billion. So this is a field that many of the companies have included within their roadmap. Tech companies have been key and to be bringing into mainstream artificial intelligence. I would even say that artificial intelligence is within the DNA of their business models. So for example, with Google and acquiring DeepMind, and you've got Microsoft working with the Montreal company Element AI, an incubator, and you've got Apple using AI for within the app stores for against fraud system, and obviously IBM Watson, who's been around for quite a while. So I think tech companies do have artificial intelligence within their DNA. So let's look at another one, transport. Transport, we know about autonomous cars, but then there's other elements where artificial intelligence is used. Right here last year, Dr. Larissa Suzuki mentioned about the smart city. And she mentioned that actually with IoT, there will be a collection of data, and then they will be using a machine learning that will help to work towards the transport and as well for pollution. And this is other examples where artificial intelligence could be used within the transport. There's many other examples, but I have only a few times. So the financial sector, like any other sectors, obviously for the financial sectors, there's the management with the consumers that will be similar to the other industries. But we have as well the compliance side, and we have the process automation. It's estimated by 2030, the financial services will be saving a cost of about $1 trillion across the different, what we call front office, middle office, and back office sectors within the companies. And let's not forget as well the retail, which it's mentioned that there's a trend which is related to personalized product for consumers. So now we looked at the industries, so as consumers, but as well as workforce, we need to understand as part of our relation that actually AI is coming into our world. Then we look at the similarities of data, obviously related to consumers. You will have consumers' patterns, which will be used across the different industry. But the other aspect that I wanted to look at is the impact on the industry business model. it is important to think that actually AI will be incorporated within the company's business model. So it's mentioned that for companies who already have a very strong innovation strategy, 62% of them are already using artificial intelligence to be able to elaborate and explore new ideas for their market. So they're already using that not only for their day-to-day, but actually to forecast and see the new ideas that can come up. So this is what I would like to say related to the AI in industry. Now let's focus back on us. Us as consumer, first of all. As you might know, last year there was the GDPR to help us to understand a little bit more about our data. And it's under consumers, it's important to focus on that. There was last year an exhibition at the V&A last May called Future is Here. I'm not sure if any of you have been there. Have you seen it? Yeah, so you've seen it. There was a launch there, which I just said I have to mention it. There was a group of universities. There was University of Nottingham, University of Oxford, and Proboscis Company. They did a fantastic project, which is called Unbiased. And basically, within 2-3 years, they brought together a toolkit. They actually have a toolkit. You can have a look on the website. And the title is actually called Unbiased, Emancipating Users Against Algorithmic Biases for a Trusted Digital Economy. So how we do that, how we will get to that, is by improving experience, educating, and not forgetting engagement for the users, which means engagement from all of us and all of you. As a workforce, so we looked at as a customer, and as I mentioned, as a workforce, it's important for you to understand that this is coming up into the company's business models and then the innovation strategies of many companies going forward. So, and let's not forget that we have different, as a workforce, we have our own regulations within different industries, and your experience and your knowledge related to that will help to the implementation of this system to be reliable and make it more a responsible AI, as we say. Let's move on to our future now. Oops, before the road. To our future. So we looked at the understanding of artificial intelligence and the importance of it, the transparency. There are some work being done for the moment related to that, and the unbiased, which we'll cover. So the 2 points that I would like to say is there are other, I would say, innovation going on as well. Ray Kurzweil mentioned there's 3 other innovations. One being the genetics, the nanotechnologies, and as well we have the strong AI. So far we're working with the weak AI. What is strong AI, or AGI, standing for Artificial General Intelligence, defined in 1997 by Mark Gubrud. So basically it's talking about intelligence to be able to do more of our task and conscientiousness, but this is another topic on its own. And I would like just to conclude to say that our civilization has always been facing challenges, and then incorporating AI do come by having everyone understanding it and understanding the impact within our futures. And as I said at the beginning, having an understanding of AI will reduce the fear that we have towards our science. And let's not forget that we will be able to incorporate it to have a better society with the technologies that we have, knowing that our society and the way that we're using data keeps increasing at the second, I would say, and we do need to have new technologies to be able to help us to handle that. So, and that I would like to leave you with one article, actually, if you can have a look. Last month at the Davos, there was an article published saying that the calculators didn't replace the mathematician, AI won't replace human. So we will have to use the technology to help us dealing with our future challenges. I would like to thank you, and I hope this Insight Talk helped you to go through the journey towards the understanding of AI. That's pretty much it for me. Do you need it? Okay.
Thank you very much, Nadia. We enjoyed that, and it's evidence from the applause that the audience did well as well. So thank you, ladies and gentlemen. Our main speaker, Dr. Krishna Gummadi, is the head of the Network Systems Research Group at the Max Planck Institute of Software Systems and a professor at the University of Saarland in Germany. The theme of his talk, Engineering a Fair Future, Why We Need to Train Unbiased AI. Please.
Good evening, everyone, and thank you for the warm applause. It's my pleasure and privilege to be here to discuss with you a topic that is quite dear to me, which is the need to train unbiased AI. Because the term AI, or artificial intelligence, means many different things to many different people, maybe to start the talk, let me actually narrow down the scope of AI systems that we're going to discuss today. The AI systems that I would like to discuss are the ones that are already in deployment and use in our society today and are increasingly influencing every aspect of our daily lives, whether we realize it or not. What we're not going to talk about are autonomous killer robots that might try to enslave the human civilization, nor are we going to talk about out-of-control self-driving cars that have to take a moral judgment as to whether they would go straight on and kill a granny crossing the street or swerve to the other side of the street and decide maybe running over a baby in a stroller. Now, not that those problems are uninteresting or extremely challenging. It is just that we have 45 minutes and there are lots of burning problems with the AI systems that are already in deployment today that we would like to focus on. So the type of AI systems that I'm going to talk about are the ones that are increasingly being used to assist or even replace human decision-making in organizations as well as governments. Now, today, you have police using AI systems to determine which areas of the city to put more policing or more police monitors. We have governments using AI systems to determine what type of social welfare policies to use and who should be eligible for social welfare benefits and under what conditions. We have the banking sector using AI systems to decide who should be given credit and who shouldn't. And we have medical sector, doctors and hospitals using AI systems to determine how to deliver healthcare to patients. Now, these AI systems impact our lives in a very significant manner, and it is worth wondering about the ethics or the fairness of using such AI systems. Now, I'm going to only touch briefly on AI systems that are also used to mediate our social interactions today. By this, I mean algorithms that are used on social media sites like Facebook and Twitter and YouTube, which end up determining what news we see, who we meet, and increasingly end up shaping what sort of opinions we hold of the world and even how we vote. Now, there are lots of ethical concerns or fairness concerns that arise in the use of AI systems that mediate these social interactions as well. But in this talk, I'm going to primarily focus on the AI systems that are used to assist humans in their decision-making. So to start with, let me point out a few scenarios where we don't have to worry about fairness issues of using artificial intelligence. These would be when IBM developed the Deep Blue machine that defeated the world chess champion, or when IBM developed the Watson AI that won the Jeopardy challenge, or when DeepMind built the AlphaGo and the AlphaGo Zero programs that ended up defeating the world Go champions. Now, the reason why we don't have to worry about fairness issues in these scenarios is because these are tasks that are extremely well defined. And what I mean by that is the rules of the game are very well defined, and the objectives of the intelligent actions are also precisely known well in advance. However, increasingly, AI is also being used in decision-making scenarios where the tasks aren't super well defined, where the objectives are at best imprecisely defined, or at worst, unclear or uncertain. Now, in those scenarios, traditionally, we as a society tended to trust humans, the human experience and human intuition and human gut feeling to make the right sort of decisions. Examples of these, for instance, would be how a professional sports team would assemble or scout for players. traditionally sports teams ended up using pretty highly paid scouts, human scouts, to assess the value of players to the team and assemble a team. Now, in 2002, Oakland Athletics, which is a professional sports baseball team in the city of Oakland, did something pretty unusual. What the general manager did was he used what is known as cybernetics, which is baseball speak for data analytics, to scout and evaluate the values of players. And in particular, they used data analysis to pick and detect players that were undervalued by human scouts of other teams. And using that insights, they ended up assembling a team on a much smaller payroll that ended up going on a world record of successive wins. Now, similarly, the area of picking stocks is something that traditionally was done by fund managers. And today, increasingly, algorithms are the ones that people are relying on to decide which stocks to buy and which stocks to sell. Now, the big picture here in the use of AI in these kinds of scenarios is that when you have lots of data about the past performance of stocks or the past performance of baseball players, you could apply statistical analysis techniques to detect some pretty sophisticated patterns or pretty deep and interesting patterns in the data that might be completely oblivious to humans. In fact, human decisions in these scenarios can often be biased. For example, the big insight that came out of the crunching of the baseball statistics, which, by the way, was detailed in a book named Moneyball by Michael Lewis, which was actually, as I showed on the previous slide, I forgot to make this point, which was also the basis for a Hollywood movie with the same name, starring Brad Pitt. So the big insight of the Moneyball strategy was that human scouts often tended to overvalue baseball players that had high overall batting average, whereas the statistical analysis, what it revealed was that there was another statistic called on-base percentage. The exact details of how it is measured is irrelevant. But this on-base percentage was more correlated with the total wins for the team. And this was an insight that was used by Oakland Athletics to assemble a highly efficient team. Now, at a slightly deeper level, what the Moneyball analysis emphasizes is the utility of testing hypotheses using big data, independently of whether or not the hypotheses are intuitive to humans. Another big advantage of using statistical analysis over big data to making decisions is that they would cut down the noise in human decision making. Now, humans are notoriously unreliable decision makers. In fact, academic studies have repeatedly shown that when you ask people to, even trained professionals, to make judgments, the type of judgments they make are highly influenced by the time of the day, the weather, the last time they had a meal, and their mood. In fact, academic studies have shown that if you look at across the different professions, whether it be in medicine or engineering or in judges making decisions about sentencing, in all these different disciplines, there is a very high variability in human decisions. In fact, studies have shown that when you ask computer professionals how long it would take to complete a software project, if you ask them on 2 successive dates and looked at the variance in their estimates, on average, the estimated time would vary by about 70%. When people have asked pathologists, highly trained pathologists, to estimate the severity of biopsy results, studies have shown that their variability of their ratings of the severity on successive dates, the correlations between them could be as low as 0.6 when 1 is the desired consistency that one would want. Now, in contrast, if you used a formula or an algorithm, or if you relied on an AI system, you would get the same output for any given input. In fact, this sort of consistency in decision making is considered so desirable by Professor Kahneman, who was a Nobel laureate and who was one of the founding fathers of behavioral economics, that in fact he makes this quote that it might be the best thing to give computer algorithms the last word to eliminate noisy human behavior. Now, the big idea of using statistical analysis and big data is often referred to as machine learning in academic world, and is often referred to as Moneyball in the literature. Now, this idea of using big data and statistical analysis has really caught the imagination of the broader public and all the decision makers, because it's very compelling to think of this as a scientific or an evidence-based way of making decisions, as opposed to relying on human intuition. Now, this has led to a push to Moneyball decision making in several different domains in our society today. For instance, there is a push to Moneyball education. There is a push to Moneyball medicine. There is a push to Moneyball government. There is a push to Moneyball social welfare policies and development schemes. And finally, there is a push to Moneyball even criminal justice. Now, let's try to dig a little deeper into what moneyballing criminal justice actually means. It's also referred to as predictive policing. And the basic idea of predictive policing is actually to reform the criminal justice system, to nudge subjective human judges who are known to have pretty strong biases and noisy behavior, and to reduce the biases and the noisy decisions. For instance, what I'm showing here is a graphic that shows how the New York police, the human New York police, were conducting stops and frisks on the streets of New York under the mayorship of Bloomberg. Now, what this graphic shows is that even though blacks constituted only 23% of the population of the New York City, they accounted for almost 53% of all the stops that the police conducted. Whereas whites and Asians and Native Americans, even though they constituted 47% of the entire population, they were subjected to only 13% of all the stops. Furthermore, there were some really interesting academic studies that showed how extraneous factors like the meal times of the judges ends up affecting judicial decisions. And this is a pretty interesting graph that appears in a proceedings for a paper that was published in Proceedings of National Academy of Sciences. And what it shows is actually how the favorability of decisions varies with the meal times of the judges. So along the x-axis, what I'm showing is the time when the judges make the decisions. This is the starting point of the day, and this is the end of the day. And the y-axis shows the fraction of decisions that they made at that particular point of time that were favorable to the defendants. And what this graph shows is two spikes at two different points of time during the day. And these are the points when the judges had the meal breaks. And what this plot is showing is the cases that were decided just before the meals actually got significantly smaller fraction of them got favorable outcomes compared to the decisions that were made by judges just after they had a happy meal. So predictive policing is meant to eliminate this kind of noisy behavior and to reduce these sorts of policing biases. And naturally, this concept has caught on, and predictive policing is now being used widely in multiple different countries, both in Europe as well as in the US and Canada as well. Now, how did this predictive policing thing work out so far? So here is an article that was published by ProPublica, which was an investigative journalism organization, about a couple of years ago. And what this organization did was they analyzed software that was used across the country, and the country they're referring to is the US in this particular case, that is used to predict whether someone would commit a crime in the future. And this tool, or this predictive tool, is biased against blacks, or was found to be biased against blacks. Next, there are predictive policing tools that are meant to forecast where a crime is likely to happen in a city next. And once again, academic studies have found that this data-driven criminal prediction fails to erase human bias. And what I'm showing here in this top graph is actually data about a predictive policing tool that was used in Oakland, in the city of Oakland. And what the top graph shows is the estimated percentage of Oakland residents that belong to different races that that were using drugs. And what this shows is that both blacks and whites in the city of Oakland were using drugs in similar proportions. However, when you looked at the percentage of the population that were targeted by predictive policing, whites were targeted at a significantly lower rate compared to blacks. So this is what this article meant by saying that the crime prediction tool is failing to erase the human bias. Now, similar analysis of tools that guide healthcare have shown racial biases as well. Now, the finding that these AI-based tools have inbuilt biases in them has risen these fears of the rise of algocracy. Algocracy is supposed to be ruled by algorithms, where we end up living in a society where all our social interactions are mediated by algorithms, and governments essentially end up becoming data-powered administrative machines where there is a math washing of public administration. In fact, Kathy Strandberg wrote a very interesting book called Weapons of Math Destruction that talks about how algorithms are pretty much guiding most decisions in the society today. Now, there are a lot of points that Kathy makes in her book that I disagree with, but I do agree with a couple of higher level points that she makes in the book, and particularly that many of the algorithms that we're using today are opaque, unregulated, and difficult to contest. And any inherent biases in these algorithms end up affecting large fractions of the populations because these algorithms can be applied at scale to large numbers of people in the society. So what we're going to do in the rest of the talk is actually discuss why, when we hoped to eliminate human biases with AI, we ended up with a situation where the whole thing ended up going quite wrong. How did all of this go wrong? This is the question that I'm going to address in the rest of the talk. So to address this question, let me actually focus on a single tool. And the tool that I'm going to focus on is a recidivism risk prediction tool. It is called COMPAS. It's built by a commercial company in the US called Northpoint. And what COMPAS does is it estimates the chance that somebody would commit a crime in the near future. Now, COMPAS, what it outputs is a score for different users. It labels them as either high risk or low risk. And these estimates are then used by judges and parole officers across multiple jurisdictions in the US. Now, the input to the COMPAS tool are a bunch of data about the features of the defendants. So in this particular case, we have the prior offenses committed by the person, and then COMPAS gives an estimate. And what you also have is data about whether that estimate proved to be right or wrong. So in this particular case, I'm actually highlighting 4 different scenarios where COMPAS actually ended up going wrong. In 2 of these cases, COMPAS predicted that these people were at low risk when actually they did offend subsequently, whereas it also sometimes marks certain people as high risk when they actually haven't committed any offenses. So the question is to understand how actually COMPAS learns who recidivates. How does it learn to make these predictions? So what COMPAS does is it trains over big data. It trains over historical recidivism data that is being collected across multiple US states. And what this data looks like is literally it has information about various different defendants, various different features about the defendants, like the type of prior offense they committed, maybe their race information, their age information, and so on. I'm only showing 3 features, but the COMPAS tool itself was trained on many more features. And along with the data is also information about past outcomes of these defendants. These are historical records of when these defendants were let go on parole, whether they actually recidivated or whether they stayed clean. Now, what COMPAS tries to do is to learn a statistical function that tries to map the features to the outcomes. Now, the designers of COMPAS were acutely conscious of the fact that their tool could lead to biased decisions. So they actually tried quite hard to avoid the bias. And the way they tried to do it is by actually excluding sensitive information like race from the data. That means they actually scrubbed out the race information from the training data before they trained the predictor. Now, in the process, what they ended up training is a tool that predicts outcomes without actually using the race information explicitly. And this is actually quite important because what this guarantees is if you have a black defendant and a white defendant with exactly the same features, they're going to get exactly the same outcomes. And this is what the COMPAS designers thought would lead to the tool being non-discriminatory in its outcomes. Now, the question is, once you remove the race information, how is it possible for this tool to actually learn to be discriminatory? Now, to understand this, we need to go one level deeper. So what I'm showing here is the data, but this time I'm representing the training data in a pictographical form. I'm showing here 2 features for the data. There may be more, but it's on a 2-dimensional screen. I can only show 2 features. And the ticks represent the people who stayed clean, and the crosses represent the defendants in the data set that actually reoffended. Now, the challenge that COMPAS faces is finding a boundary, a linear boundary that is a straight line that separates the 2 classes of points, the ticks from the crosses. Now, as you can see, there are a number of different straight lines that you can draw on this picture, right? In fact, you can draw infinite number of straight lines cutting the points. Now, the goal, however, is to pick a straight line that does the best job, that is optimal in terms of separating the ticks from the crosses. So, for instance, one such a line is that one. Notice that there is no perfect boundary. There is no straight line boundary that would perfectly or cleanly separate all the ticks from the crosses. So we have to deal with some amount of inaccuracy, but this is one of the best possible straight line boundaries that you could find. Now, how exactly does COMPAS find this? Now, this is where the mathematical optimization part of machine learning comes in, where we actually define certain functions that we optimize to learn this boundary. Now, the technical details of how we actually do that optimization are irrelevant for our talk for now. But the question is, so far, things seem great. How is it possible for this boundary to be actually biased? To understand this, let me finally reveal the different races that these points represent. So what I'm showing now are the 2 races that are in the population, the orange race and the blue race of people. Now notice that this picture now all of a sudden looks very different. The question now to ask is this boundary that we learned optimal for all the subgroups in the population? The answer is actually no. In fact, if you look at the number of errors that this boundary that was optimal or that was pretty accurate for the overall population, if you look at what fraction of yellow dots and the blue dots does it go wrong for, you notice that it makes very few errors for yellow, but it makes a lot of errors for the blue dots. In fact, the type of errors that it makes are also quite different. For the yellow race, people who are guilty are being declared innocent, whereas for the blue race, people who are innocent are actually being declared guilty. Now, in some sense, this should not be too surprising, because when you try to find a decision boundary that is best for the entire population, you're not guaranteed to find a boundary that is good for individual subgroups within the population. In fact, it's quite possible that you would trade off more errors for one group for fewer errors in predictions for another group. And that's exactly what is happening here. In fact, this is what explains the disparity or the inequality in the error rates for different races of COMPAS. So what I'm showing here is a data about the COMPAS estimates for defendants in a county in Florida called the Broward County. And what I'm showing here in the top row is information about people who actually recidivated. And the second row shows information about people who actually stayed clean. The columns show the risk estimates provided by COMPAS. And we have two separate defendants and the other for the white defendants. Now, if you compute what is known as false positive rate, which is the fraction of innocent people that were wrongly declared guilty for the two different races, you would find that the false positive rate for blacks is considerably higher, almost twice as high as the false positive rate for whites. And this means that the tool is significantly worse for blacks than for whites, if you compare based on the false positive rate. Next, we could look at the false negative rate, which is nothing more than the fraction of guilty people who were declared, who were wrongly predicted as innocent. And here, once again, black defendants have nearly half as much false negative rate as white defendants. Now notice that in the case of false negative rates, having a higher false negative rate is an advantage. So in this particular case, it's significantly better for whites than for blacks across both the error rates. And this is the sort of analysis that led ProPublica to publish this article calling out about machine bias by the COMPAS tool. Now that we sort of understand where the bias in the COMPAS predictions are coming from, let's talk a little bit about how would we learn to avoid this discrimination. Now, let's try to understand where the problem is coming from. The problem is because of the learning objective. In machine learning, traditionally, people pride in making accurate predictions. But what is often not well thought through is how exactly are we measuring accuracy of the predictions? Now, typically, accuracy of the predictions, which is the learning objective, is to minimize the error rate for the entire population. But this ignores the group error rates or the error rates for subgroups in the population. Now, if we want the tool to be non-discriminatory, we would need to change the learning objective. That is, we would need to specify that we would want to contain or constrain the inequality in the group error rates during learning. And what this would mean is adding an additional constraint to the optimization problem, where we say we not only want the tool to minimize the overall error rate, but we would want it subject to the condition that the error rates for blacks is the same as the error rates for whites. Now, if we learned this new function, if we solved this new optimization problem instead of just the first one, then we would avoid a disparity in the error rate. Now, a few observations about this new formulation. First, what we're doing by adding these constraints is we're embedding ethics and values in the learning process. However, there is no free lunch here. Anytime we add a constraint, anytime we add an ethical constraint, it actually leads to a decrease in the overall error rates. And this is something that you do have to give up. And in some sense, what we end up having is actually an ethical choice between how much we care about minimizing the overall error rate of the population versus how much we care about equalizing the error rates across different groups in the population. Now, these are some trade-offs that we, as designers of the tools, have to specify. Now, when you're trying to do ethical learning or fair learning, there are a number of different types of ethical dilemmas one faces. Now, what I showed on the previous slide is a dilemma between trading off overall errors, overall population errors with group errors. But there are many more interesting and intriguing ethical dilemmas that one encounters in the process. For instance, even talking about group error rates, which type of group error rate should we try to equalize? For instance, I've already shown two different types of group error rates, false positives and false negatives. In fact, there are two more types of errors that one could define, which are false omission errors and false discovery errors. False discovery errors are the errors that where you measure false discovery as a fraction of predicted guilty that are actually innocent, whereas false omission would be the fraction of predicted innocent people that are guilty. And trust me, these four different error rates are actually quite different. Now, what is even more striking are some recent results where some researchers have shown that it is impossible to simultaneously optimize or equalize all these error rates across different groups in the population if the underlying base recidivism rate, that is the fraction of blacks and whites that actually recidivate, if the underlying base recidivism rates in the society for different groups are different, it's impossible for a machine decision-making system or a human decision-making system to give decisions so that you equalize all these error rates. So these are the kinds of ethical dilemmas that one faces in fair learning. That means the designers have to pick and choose which of the error rates is more important for them to equalize. Or a different way of looking at it is, no matter how you design a decision-making system, there is going to be an error rate for the different groups along which you would be different. So when we talk about a future where we would want AI systems to be assisting human decision makers, what we need are actually humans to think more carefully about setting the learning objectives instead of just using these machine learning models as black boxes and trusting that they are somehow optimizing for accuracy. And simultaneously, where we can actually efficiently use the machines is in terms of learning patterns in the data that actually target the objectives that are specified by humans. A lot of my work in the past couple of years, and in fact, this is work done by many of the students, PhD students who are working with me, are in the area of solving the technical challenges in defining these sorts of objective functions and optimizing for them. Next, now that we have realized that part of the reason, or at least one major reason for unfairness or bias is defining fair objectives, let's ask if fair objectives are sufficient to train unbiased AI. Unfortunately, no. The reason is we haven't yet talked about potential biases in the training data itself. Recollect that COMPAS actually tries to learn from big historical recidivism data. Now, in this data set, certain races might be underrepresented, leading to what is known as sampling bias. Now, you might wonder, why would certain races be underrepresented compared to others? Well, the reason is, just think about the process by which this data set was generated. It is a data set about people who were let go on a parole in the first place. But if human judges who were actually granting the parole in the past were biased, then there may be fewer people of a certain race that were actually let go on a parole, and therefore there will be fewer data samples about them in the training data. In fact, if if the parole decisions were biased against blacks in the past, there would be fewer samples about black defendants in the training data set. And this could again lead to biased learning. Another type of bias that might come about is what is called as a labeling bias. This is one where the accuracy of some of the data in the training data set itself is questionable. For instance, so far we assumed that the past outcomes are actually reflecting the reality of whether or not a person recidivated in the real world. But sometimes these past outcomes are actually not real world outcomes, but instead they are estimates by human judges who we know can be biased. And therefore there can be labeling bias where the human judges who are actually providing this training data might wrongly label or biasedly label certain groups of people. And these biases, in turn, would be picked up by the learning algorithms. In fact, there are many instances where this sort of training data bias ends up affecting the predictions made by predictive policing. For instance, let's go back to this article that I mentioned before that actually pointed out that the crime prediction fails to erase human bias. Now, why is that? It's because this crime prediction tool was trained on a data set of crime reports that were compiled by the police department in the city of Oakland. Now, this crime statistics that were compiled by the police, actually, these are crimes about the drug-related crimes. They differ significantly from another data set which actually estimates the drug use in the city of Oakland. Now, unfortunately, the city of Oakland has pretty strong segregation in terms of there being certain neighborhoods in the city that are majority blacks and certain other neighborhoods which are majority white. And so when the crime statistics that were compiled by the police were actually used, this leads to the predictive tool mimicking the biases in the compiled crime reports. Now, the point that I would like to emphasize here is the risk of a vicious cycle. And this vicious cycle might be set up because when you have a predictive tool that sends more police to majority black neighborhoods, that might lead to more crime being reported from those neighborhoods, which in turn ends up confirming the biases of people that there is more drug-related crime in certain areas of the city. And that in turn leads to the next generation of predictive policing tools sending even more police towards those neighborhoods, and so on. So this can end up quickly creating a vicious cycle. Another pretty striking example of training data bias is, and how it affects predictions, is in the context of gender classification. So recently, some researchers from MIT Media Lab analyzed facial recognition software, commercial facial recognition software that is built by multiple different companies, including by IBM and Microsoft. And what these tools were trying to do is to identify the gender in the pictures. Now, these sorts of tools are widely used on social media applications as well. Now, what these researchers found were when they looked at the accuracy of gender identification of lighter-skinned males, the accuracy of the tools, like for instance, the IBM tools, was as close to, is higher than 99%. But the accuracy for lighter-skinned females, as well as darker-skinned males, is significantly lower at around 90. Now, what is actually shocking is when it comes to darker-skinned females, the accuracy falls as low as 66%. Now, notice that in these kinds of situations, even if you did a random prediction, you're going to be 50% accurate, right? So this is pretty strong bias, and it is shocking that something known as intersectionality in discrimination, where a group of people, the darker-skinned females, are suffering because of being discriminated, both because of their gender as well as their skin color. So what I hope that you would take away from this discussion is that if we want to have AI systems that assist humans to make decisions in a fair manner, we need humans to define fair learning objectives, but we also need humans to gather unbiased training data. Now, once again, let's ask the question, are we done? If we gather unbiased training data, and if we define the objectives carefully, would we be able to train unbiased AI? Unfortunately, no. And to understand the next source of bias in AI, it's actually going to be a little bit tricky. We need to understand what are commonly referred to as latent representations of knowledge in AI. So to understand this, let me actually start off with an observation. There are some types of knowledge representations that are more intelligent than others. Now, this might sound strange, because it's not often that we use the word intelligence with a representation of knowledge. Now, to understand why, let me take the simple example of the two popular representation of numbers that we all have. The first is the Indo-Arabic numeral system, and the second is the Roman numeral system. Now, if I ask you to perform some arithmetic tasks in one representation of numbers versus another, like a simple addition or a multiplication, you would immediately recognize that the Indo-Arabic numeral system is significantly more easier to manipulate compared to the Roman numeral system. Now, in fact, this is because it is a positional numbering system that has some several deep advantages just because it has the number 0, which is partly imaginary number. So what I want you to take away from this is the power of representation. Sometimes the symbols that we use to represent information can actually enable us to manipulate those representations far more intelligently than other types of representation. Now, some of you might have heard about a subfield of machine learning that has enabled significant advances in the processing of natural language text, speech, and images, and that is deep learning. Now, at a very, very high level, you can think of deep learning as training of neural networks that are trying to find intelligent representations of very high dimensional data. Now, the problem is biases in these latent representations. And these can be notoriously difficult for people or humans to detect or understand, unlike the types of biases that I talked about before in terms of the learning objectives or the training data. So for instance, about a few years ago, there were researchers at Google developed a tool called Word2Vec. And what it does is it maps every word in natural language like English to a vector in a very high dimensional space. And this vector has often, sometimes has like 100 to 300 dimensions. Now, here is a representation of those vectors for some of the words in just 2 dimensions. Now, these vector representations are intelligent in the following sense. If you take pairs of words like man and king and woman and queen, pairs of words that are similarly semantically related tend to be similarly positioned relative to each other in this high dimensional space. And what this means is if you looked at the vector connecting king to man and the vector connecting queen to woman, those 2 vectors would be in the same direction and would have the same magnitude. Now, in the process, what this representation captures is what is known in natural language processing as distributional semantics, and these sorts of patterns are extremely useful for a number of natural language processing applications. For instance, you could use this to solve analogy puzzles, like man is to king as woman is to queen, or Paris is to France as London is to England. Now, unfortunately, these intelligent representations exhibit certain really strange biases. So in fact, researchers started playing with these analogies, and then one of them asked, man is to computer as woman is to what? And the answer came out to be this. And then they asked, father is to doctor as mother is to what? Now, notice that these pretty offensive stereotypes are actually embedded in these latent representations of these words that are learned by these AI systems. In fact, in a recent study, some researchers have shown that a number of gender-neutral professions are strongly associated with one gender or the other in word embeddings. So for instance, occupations like receptionist or hairdresser are, if you look at their positioning, they're much more closer to the female pronouns like she, whereas occupations like architect and fighter pilot and warrior are more closely located to the male pronoun he. Now, these latent representations or biases in them represent a very deep and troubling phenomena. The reason being, these latent representations are not meant for humans to understand. They're meant, or they've been engineered for machines to enable easy manipulation. And so humans are not going to be able to predict how these biases would manifest when you start building applications on top of them. And an example of this is the surprise or unfortunate shock that people faced when they tried to do, when they discovered gender bias in machine translation. So this is an example where people used Google Translate to translate Turkish to English. Now, I'm not familiar with Turkish, but I was told that the pronoun bir in Turkish is a gender-neutral pronoun. But Google Translate maps it to he when it is an engineer or a doctor, and she when it is a cook or a nurse. Now, the problem with these, now one could argue whether, or one could point out that these representations in some sense are being learned from a corpus of data. For instance, the Google's word2vec was learned from Google News data corpus, and therefore whatever the biases that are being learned are the stereotypes that exist in the society. But the problem we have is that if we're going to build applications on top of these latent representations, we're going to be using AI to reinforce the existing societal inequities and societal biases, rather than move towards a more fairer society that we would all hope to live in. So, to conclude, if we want to train unbiased AI systems that can work with humans to make unbiased decisions, what I pointed out was that we need to be careful in defining the learning objectives that are fair, and we also need to gather unbiased training data. And in addition, we also need to ensure unbiased latent representations. And the reason I marked the last one in red is because I am unfortunately pessimistic that we could actually detect the different possible biases that one would have in these latent representations. Latent representations are notoriously difficult for people to understand or even to explain. How do you explain a word represented with a 300-dimensional vector to humans and expect them to understand the kind of biases that might be embedded within them? So with that, I would like to conclude the talk, and thank you again.
Thank you very much, Professor Gummadi. Well, I think that was fascinating, wasn't it? Yeah. Oh, I hear a lot of ums there. That was good. Now, we're going to have a little session of questions and answers just for a few minutes. I think we've got about 20 minutes or so. So just prepare something straight away. we'll come back to you in a moment. So if we can invite Nadia back to the platform as well. I'd like to thank you, Krishna, very much for that. Now we've got a, who's got the microphone? Okay, so Debbie's got that microphone there, which is, it's a kind of, we throw it about a little bit, that's what happens with it. Apparently she's very good at aim, but you know, be careful anyway. You'll see that it's a white cube. If you can speak into the black patch at the top with the white cross in it, then we'll be able to hear you. Please wait for the microphone to come to you before we ask your question. So you better get your cricket skills ready. Well, that's a gender-biased term, isn't it? Catching skills. So let's get hands. Who would like to ask a question? Please, gentleman in the red top. Thank you.
Sorry, Neville Hazel. If you were in front of a group of MPs, what would you say to them about regulation of AI?
Do you want to go first?
Would you like
Please do.
Yeah, please
No,
go
no,
ahead.
please. Good. I'll jump in.
I was about to cop out by saying that I'm an academic researcher, so I feel so. There is clearly regulation that is needed. Now, the way I see the current state of affairs is that there are a lot of fundamentally interesting problems about the way AI systems are being designed today that are not yet completely understood or solved even by people in academic research. So at this point, I would be hesitant. So I do think there is regulation needed, but in terms of, but for now, my focus has been more on trying to understand some foundational challenges that arise in the design of the AI system themselves. And I haven't spent much time thinking about the regulation side or regulatory side. We did do some work in like very, very specific narrow areas where we, in some of our recent research, where we had proposals for how to avoid discrimination in ad targeting and so on, but it was much more narrowly focused than very broad thoughts on AI regulation. I'm not the expert in that area, I'm afraid.
So I will just add to what Krishna said. So the reason why I think it's important to have an understanding of AI and where it comes from, because when we look at the history of AI, we had winters of AI in the 1980s with the expert system, and I'm sure many of you would know what there was a hype, and then there was there was a decline of it. So I think there will probably be regulation. There are so many talks going on right now to be able to build a responsible AI. I think if we're not careful, there may be some winters of AI as we had within our history. So hence it is important as well for the general public to build up an understanding of what AI is, and then to be able to participate into that, as I was mentioning, within as a consumer or even as a workforce. So I think this is something going on, but yeah. Does that answer your question?
I think the early curveball was handled really nicely. Thank you very much. Very good. So let's have a few more hands, please. Please. Gentleman just here in the black.
Which, this one here?
Yep. Or we're going to throw it. Very good.
Yeah, I'm glad I caught it well, because I wanted to point out that my daughter's a very good cricketer and she would very much enjoy showing her cricketing skills here. So please don't take that as an example of latent bias. But I work in quality assurance for a firm called Geckoboard, and I'm quite interested in how you'd see the role of quality assurance in developing AI.
The role of quality assurance. Who'd like to take that?
In insurance.
Quality assurance.
Quality assurance.
All right, okay. So I think, so what would you like to know exactly? So just if you want to...
Well, in terms of software at the moment, we're interested in unit tests, code reviews, and integration tests, and things like that. But actually, it seems to me the role of quality assurance in AI will be quite different. And
Yeah, so
actually, how would we guarantee that people are going to get what they want?
right. As part of one of, and I see where you're coming from. So as part of one of the current debates going on is as well related to the life cycle of the systems using AI. So there's quite a lot going on in there as well to make sure. I mean, you covered quite a lot of the issues related to the biases within the algorithm, and that is if when you try to use these softwares within companies and then your business models, you have to make sure that the life cycles of the system using these algorithms are quite sure. The other aspect as well that I wanted to mention is what we call the safety critical system aspect, which is to ensure the reduction of the level of errors. So there are quite a few works related to that as well.
Yes.
But definitely related to the life cycles. I've seen so many discussions related to life cycles of systems which might be embedded into their software's algorithms, and then to see how that overall as a software we're going to manage that. Yeah. Does that answer your question? Yeah? Right.
If I can just add a couple of points to that. Increasingly, there is a greater realization among companies to ensure that the tools that they're designing meet certain ethical standards. For instance, even IBM and Microsoft were the developers of the gender classifiers were genuinely shocked that their tools were performing that poorly for certain groups of people. And this sort of awareness is increasingly growing. And there is, at least in my interactions with technology companies, there is a greater awareness of the need for fairness, accountability, and transparency, as Nadia mentioned it. In fact, pretty much all the big tech companies today, whether it is Facebook or Twitter or Microsoft or Google, have research teams that are actually called fairness, accountability, and transparency teams, whose primary goal is to think about issues related to fairness that arise across a wide range of products they develop. And in addition to that, there are these watchdog groups that are increasingly auditing algorithms that are being widely used. And sometimes these watchdog groups end up being people in academia who end up studying the tools that are deployed for biases and unfairness.
Yeah.
Thank you, Krishna. Please, down the front.
Thank you both for a very learned presentation on a very complex subject. I've got a very simple problem to ask you. If I may make an artificial division between analytic intelligence and emotional intelligence in humans, do AI have anything to contribute to emotional intelligence, and can, at the moment, contribute towards understanding the culture of bullying and bigotry that depress the per capita output of the ordinary working people, not to speak of the honorable parliamentarians?
So that was a simple question.
Oh yeah, I know.
That's quite loaded.
I don't even want to listen to complicated one. This one is an easy one. So
We're looking at you, Krishna.
Okay, so I could give it a shot. So the word emotional, so the question of whether the word emotional intelligence is something that I'm not quite sure machines are capable of. We could talk about ethical intelligence, where you talk about for instance, you could capture your ethics by the way in which you define the objectives for the intelligent actions. So I do think there is a scope for capturing ethics as intelligence, but it's not clear to me that this notion of emotional intelligence is a bit more complicated, in my opinion, to capture in AI. Now, having said that, you also touched on another topic, which is whether one could build AI systems that end up detecting hate speech or divisive speech and these sorts of things. Now, there are tools that people are developing which are increasingly getting better at identifying bullying speech that corresponds to bullying or hate speech and divisive speech and so on. And there is rapid progress being made in that area. However, there are still some deep ethical questions that come up when people start disagreeing on what constitutes hate speech.
Nadia.
So on this one, when we look at the emotion, I had in mind, maybe you wanted to talk more about what I concluded to talk about artificial general intelligence and about the conscientiousness. I think we're quite away from that. But then when you mentioned, as Krishna mentioned, about the bullying and the terminologies, then the machine doesn't need to be conscious about it. It's purely analysis of the data. So there are some algorithm and obviously examples that Krishna mentioned that they're focusing on that. But I think they're two, probably, I would see it as two different topics. And then when I hear about emotion, I think automatically about AGI more focusing. And then I think this is a whole new topic, because then when you go into AGI, you start thinking about there's debate related to conscientiousness about it, the emotions, and then you move more and more towards the psychology and other, but that's sort of whole other field. So for the bullying, yes, there are work going on, and then for emotion, I think this is the AGI field. Does that answer your question? Yeah? All right.
I think in cricket parlance, to carry on that was a googly, really, not a straightforward question. But thank you very much for that. Please, go on, go for it, Debbie. It's about 30 feet.
Shall I?
Oh, nice.
Right. So, Dr. Gummadi, you mentioned one of the ways that we can potentially avoid training bias algorithms is by gathering unbiased data. My question is, how can we do that if possibly all the data that we have in the world is biased?
So you're raising an interesting question, which is sometimes when we envision what the data might look like in a future society that is fair, that is essentially some data set that is counterfactual to the data sets that we have today. So how do you generate those kinds of data sets? Now, people are exploring different types of options, including ones where you actually generate the data sets that represent the society that you would want to be like, and then train on that. But there's also very interesting work that is being done considering how decision making, once it is deployed today, ends up affecting the characteristics of the society of the future. So in the talk today, I didn't touch upon the dynamics of the society. That is, I always assumed that there was some population that had a certain features, but in reality, depending on how you make the decisions, the features of the population would evolve. The population would move from where they are currently to some other, to a different distribution. Now there is work that is being done by my group as well as others that actually are arguing increasingly to take those long-term impacts of decision-making also into consideration and not view the decision-making just as a problem where you're trying to make the most accurate decisions for the population as it exists today, but to include these or to consider these long-term impacts into the decision-making process. Of course, these things make the learning models a lot more complicated than what I mentioned, but that's a part that I didn't discuss today.
Thank you. I'm feeling a little bit gender biased and height biased because I don't think we can shy the microphone up there. Please, thank you. Just here, Debbie.
Hi. I'm interested in your thinking around fair questions and how you
make the trade-off between increased customer personalization. That says, as I look to personalize the decision making for a particular customer or a particular customer set, I'm actually decreasing my the people I'm thinking about, and therefore a fair question for a subset or a much smaller number of people may not be fair at a more general level.
Mhm.
Have you thought about that?
Yes. So you're raising a very, very interesting question, which is, for instance, say, going back to the tool that I was talking about, would a right decision be to actually train two different recidivism risk prediction tools, one for one segment of the population and another to another segment of the population? Now, this actually raises or opens up another can of worms about whether in a society we would want different prediction models for different groups of people, or whether we would want the same prediction model. Now, in certain scenarios, having different prediction models makes obvious sense. So, for instance, if you're talking about healthcare decisions, it might make sense to have models trained differently for different genders, say, for instance. But when you're talking about predicting recidivism risk, once again, that's a bit more of a tricky issue, and it really depends on the societal consensus around it. Now, if you're asking purely from an information theoretic or machine learning perspective, could we do better by actually personalizing the decisions to smaller groups of people? Absolutely. But the tricky issue is whether society would actually accept having different sets of rules for different groups of people. Like, for instance, take university admission decisions. There would we be fine with having different sets of rules for different groups of people? It really depends on the decision-making scenario. But in general, the more you could personalize, the better it would be. But there is the ethical issues that come in based on the scenario.
Thank you. Just there, please, Debbie. Got one with the glasses. Just there, I was thinking, actually. Nope. Blue. Good there's so many hands, but...
Hello. Hopefully this is a slightly easier question. I seem to have missed the point on the COMPAS system as to where the intelligence is in it. It seems to me you're just getting a lot of unbiased or biased data from police headquarters and things like that, number crunching it and coming out with an answer according to a pre-selected algorithm that we've knocked off the black and white bit, or you tinker with it. Can you explain where the intelligence is in that COMPAS system? Because I've missed it completely.
That's an interesting question again. So one way of comparing the intelligence of the system would be to compare the accuracy of humans making those predictions versus the algorithms making those predictions, and comparing their relative accuracy. So what COMPAS is trying to do is to make the predictions that match what is being observed in the training data, right? So in some sense, it is trying to make the predictions using the features of the defendant, right? So in that sense, it is trying to do an intelligent prediction. Now, it's a question. Now, I guess maybe if the question is the performance striking, is the performance of the COMPAS tool striking one as intelligent? But that's talking about intelligence in a more relative scale than in absolute terms, right? Or maybe I'm So So COMPAS is learning in the sense that it is using the features in the training data, and it is selecting weights that it has, how much weight it has to put on each of those features when making the predictions. So what it is learning is how much weight or importance to give to the different features in the training data. Now, of course, in the simplified examples that I was showing, the training data had only 3 features, and out of which, if you removed race, there was only 2. But in practice, there were actually 8 different features that the tool was using. And it was trying to learn from the data how much weight to put on the 8 different features to make these predictions.
Yeah, good. Thank you. We're bang on time to say that's bang on time now. None of those questions were simple, were they? But I think you'll agree that the answers that Krishna and Nadia gave us were excellent. And I think just a round of applause, please, for our speakers.
Thank you.
So you notice this is a BCS and IET event. Shortly, we're going to be working on a little bit more together, particularly around the skills area in AI. So if you see an email pop up in your inbox shortly for a survey about that, please do answer it. We'd love to get your input into that. The Turing Trust was founded in 2009 by Alan Turing's closest family in honour of his remarkable legacy. We see some nice pictures there. Its mission is to promote education and training across the use of information technology to schools across Africa. Over the last 10 years, the Trust has improved access to education in 141 community-based schools, sending over 5,000 computers to Malawi, Ghana, Liberia, and Kenya through a computer reuse scheme, which is an excellent and laudable thing. We very much appreciate the input that's been given by our 2 speakers. We'd like to thank you for your attendance and your questions. This material will be available online to view later. If you'd like to view it again, we invite you to join us in the registration area for some drinks. And also, please check out the showcase. One and all, thank you very much.